InterOpsis is a sovereign cyber authority system designed for one specific condition, not when everything is functioning normally, but when systems are degraded, contested, or actively compromised. Most security architectures focus primarily on prevention or detection. InterOpsis is built for the point at which control itself begins to fail. This technical demonstration shows how that system can be represented through 4 expressions: activate, agent, engine, and live, using a bounded mock operational scenario. The system is expressed as a progression. Activate is the lightest expression, a doctrine overlay applied to existing environments. Agent introduces local enforcement at the execution layer. Engine is the full bounded operational system expression, the deployable environment in which doctrine becomes executable. And live is the continuously operating state of that system, where the control loop remains active in real time. These are not unrelated products. They are one architecture expressed at different levels of operational control. Technically, InterOpsis is organized into 4 strata. At the top is the user interface layer, including the operator console and the facilitator console. Beneath that sits the control plane, composed of TrustNet, DNA, Success Matrix, and Data Guardian. Under the control plane is the runtime layer, where the enclave orchestrator, Flash, QuickStrike, and SecureTrain operate. Beneath that runtime layer is the infrastructure substrate. Initially hardened Linux with KVM or Proxmox, local encrypted storage, and trusted hardware boundaries. This layered structure comes directly from the internal system architecture and implementation mapping. This is activate. In this expression, InterOpsis is not replacing the existing architecture. It is acting as a doctrine-bound activation layer over an existing workflow or decision environment. Its purpose is to measure whether control, containment, and bounded behavior remain intact under stress. What the dashboard is showing is a comparison between workflow behavior without doctrine and workflow behavior with doctrine applied. Architecturally, Activate remains external to the system it is evaluating. It sits above a workflow rather than inside it. It observes inputs, decision paths, and outputs, then applies doctrine-bound evaluation. This is why it is the lightest and fastest expression. It can answer whether a control problem exists under degraded conditions before a deeper operational commitment is required. It is best understood as an evaluation layer, not a replacement layer. This is agent. The shift here is from observation to enforcement. Agent is described internally as an installable control agent that applies doctrine-bound enforcement at the local execution layer. In this view, the local control node is monitoring execution, evaluating policy alignment, and actively blocking or restricting actions. The key technical point is locality. This expression exists at the point where the action happens. This diagram shows the local architecture of agent. The agent sits inside the environment, interfacing directly with process behavior, data movement, and event logging. It can optionally synchronize with the broader control plane, but it does not require that synchronization in order to remain meaningful. The architectural purpose of agent is to preserve bounded execution even when upstream assumptions degrade. This is InterOpsis engine. At this level, the system is no longer a light overlay or a local component. It is the full bounded operational system expression. The environment is segmented into controlled enclaves. One enclave in this scenario is compromised. The important fact is not the compromise, it is what happens next. The system contains that enclave, preserves the other enclaves, and maintains mission continuity. This is the containment view. The runtime model implements enclave separation rather than assuming a flat environment. The internal deployment blueprint defines multiple enclave types, each hardened and governed under doctrine. In this mock view, one enclave is marked compromised and communication paths to the rest are blocked. The technical point here is structural containment. The mechanism is bounded separation and controlled communication. This is the runtime control sequence. Detection begins with Flash, the telemetry and early detection layer. That event is then evaluated in the context of authority and policy through TrustNet and the control plane. QuickStrike applies the governed runbook action. In this scenario, isolation and containment. The result is a system that moves from event to governed decision to action without improvisation. This is SecureTrain represented as software. The architecture includes a scenario engine, facilitator controls, doctrinal scoring, and after-action generation. In the mock demonstration, a compromised operational enclave scenario has been selected. The facilitator can start the scenario, inject follow-on events, and generate a scored after-action output. This shows that the system is not only intended to operate under stress, but to be repeatedly evaluated under controlled conditions. This is live. Live is best understood not as a separate stack, but as the continuously operating state of engine. Here, data is streaming, events are being processed continuously, and actions can be triggered in near real time. The runtime, control, and scoring functions shown earlier are no longer episodic. They remain active as an operational loop. This mockup visualizes that continuous loop from an operator perspective. Live events, live doctrine scoring, and action history. These are the code and tooling choices behind the architecture. Rust is used for agents, orchestrators, and security-sensitive runtime services. Go is used for API, collectors, and control services. Python is used for simulation logic and offline AI or ML training. TypeScript is used for the operator and facilitator interfaces. The practical runtime substrate is hardened Linux with KVM or Proxmox, supported by local encrypted data stores. The build model is as important as the runtime model. Development is intended to occur in a dev enclave. Source control is local. Builds are deterministic. Testing occurs before promotion into a staging enclave. The goal is a controlled path from code to test to bounded deployment without reliance on external runtime dependencies. That development and deployment discipline is already reflected in the internal repo standards and engineering roadmap. If this aligns with the environments your team is responsible for, the next step is a structured evaluation. That evaluation begins by identifying a relevant scenario, degraded conditions, contested environments, or AI-enabled workflows under stress. From there, the appropriate InterOpsis expression can be selected, activate, agent, or engine, and reviewed through a bounded operational walkthrough. No large deployment decision is required at that stage. The objective is straightforward: to determine whether control, containment, and mission continuity actually hold under the conditions that matter most. For coordination or evaluation planning, contact Manuel Lloyd at the address on screen.